So an example would be like y equals 2x plus 3. And then instead of y, actually it'd be f of x. F of x equals 2x plus 3. Y equals the absolute value of f of x. So if it says that y equals the absolute value of f of x, you fill f of x into those absolute value signs, right? So we'd actually have y equals the absolute value of 2x plus 3. Now remember, absolute values, whenever you take the absolute value of anything, it's the distance from 0, so it's always positive. So really, it's going to take that 2x plus 3 graph and reflect anything that's below the x-axis above it, right? Because you can't have any negatives. So I always draw my original line first to get my piecewise function. 1, 2, 3. So I have a y-intercept of 3. And then I go rise up to right one because they're positive. Oh my goodness. Up to right one. So now I ran out of room. So what can I do to get points down here? Down to, how do I go the opposite direction of slope? Instead of up to right one, I can go down to left one. So the red line itself then is just y equals 2x plus 3, right? What I tell you is important about piecewise functions. In order to do piecewise functions, what do you need to know off the graph? Where does that graph reflect up? At the x-axis, right? So the turning point where it's going to change is going to be your x-intercept. So you always have to find the x-intercept of the original graph always. So you need the x-intercept. And septs in brackets. Because if it's a quadratic, you'll get 2 x-intercepts, maybe 1 or none. If it's linear, you'll only get 1 x-intercept. So I always find the x-intercepts off my original. 0 equals 2x plus 3. Negative 3 equals 2x. Divide by 2. And x equals negative 3 over 2. Or you could say negative 1.5. And that's important because that's where the graph is going to change from one piece to the other, right? Now, everything below this, when I find the absolute value function, is just going to reflect up. So if I'm at negative 2 and negative 1, I'm now going to be at negative 2, positive 1. Oh, I hate Smartboard. And then here I'm at negative 3 and negative 3, so I'm going to be at negative 3 and positive 3. And then I'm going to get this, right? What equation is the green if it's not the original? It's just the negative version of the original, right? So if this is 2x plus 3, this one's going to be negative 2x minus 3. Because it just changes all the signs of the original. So now we work our pieces from left to right. So we can go y equals, what's our equation on the left here? 2x minus 3. If x is less than or equal to what value? What's the changing x? What's that changing x? Negative. Then on the right of 1.5, I follow the original equation, 2x plus 3. This story is supposed to have a negative. 2x plus 3. And you have your pieces. So you always want to draw your original and label it. Then reflect your original and label that, and get your x-intercept so you can actually say where it changes. Okay, there's 3 steps. The original equation, draw it, reflect it, get your new equation, and get your x-intercept so you can get your pieces. Okay, I want you, the original is going to be f of x equals negative 2x plus 4. And I want you to find the absolute value of f of x as a piecewise function. So you try that one out. Okay, so we're finding the x-intercept, so that's why y becomes 0, right? And then you divide by negative 2. Whenever you're finding the x-intercept, y is 0. So x equals 2. So we know at 2, the original graph's going to exist and the new graph's going to exist, right? That's that shared point they have. It's called the invariant point. So 1, 2, 3, 4 is my y-intercept. Oh, my smartboard is always off like an inch. It's driving me batty. Down to right 1, down to right 1, down to right 1, down to right 1. So let me label that one. Y equals negative 2x plus 4. So actually the original equation is going to be the left one, right? And why does that happen? Because it's decreasing. It has a negative slope this time, not a positive. And then here we're going to go 2, and then 4. And then this equation is represented by y equals positive 2x minus 4. Because remember with absolute values, you get case 1, you get a positive case, and you get a negative case. Same thing with the absolute values when you're drawing the graph too. So now when we write the piecewise function, oh, come on. You have to push like here in order to... Okay, I'm back, it's fine. Y equals, on the left one, it's going to be negative 2x plus 4. Oh, negative 2x plus 4. When x is less than or equal to 2, and then positive 2x minus 4 when x is greater than 2. Does it matter if this one has the equal sign or this one has the equal sign? No, just pick one of them to have it. All that matters. Okay, now we didn't just do absolute values of linear, we did absolute values of quadratics as well, right? Same steps. Find your x-intercepts first. Except your x-intercepts from quadratics, you're going to have to either factor or quadratic formula to get your x-intercepts, right? Draw your 2 graphs, reflect them, and then do your piecewise function. So let's see if you can do this one. Y equals, sorry, not y equals, f of x equals x squared minus 2x minus 3. Determine y equals the absolute value of f of x as a piecewise function. So try that one out. Same steps. So first off, you want to get your x-intercept. X equals x squared minus 2x minus 3, or 0 equals, sorry, x squared minus 2x minus 3, and it's 0 because x-intercept means y is 0. I'm going to factor it. What times what gets me negative 3? What plus what gets me negative 2? Negative 3 and positive 1. And I can go right and put it in brackets because I have a 1 in front. X minus 3, x plus 1. Remember, if it was a negative 1 in front, I'd still have to do decomp. or move it all to the other side. Then I solve these out, and I get x equals 3 and negative 1. So that's the first thing I'm going to do. Okay? This graph is concave up because there's a positive leading coefficient. Did anyone find out what the minimum value is? Do you know what the minimum is? 1 and negative 4. Now you could have done that by completing the square, or you can just go to your calculator, right? Is there any other coordinates up here so I actually have some arms going in the right direction? Does it really matter? Meh. My arms go up like this, right? Now I label this as my original graph. So this is y equals x squared minus 2x minus 3. This arm is y equals x squared minus 2x minus 3. I like drawing the original and the reflected in different colors so that I know the original is whatever the color I have is, and then the new is a different color. So now instead of being at 1 and negative 4, I'm going to be at 1 and positive 4. And this part of my graph will go away, right? It doesn't actually exist. So on the absolute function graph, that's all I should have. Nothing below the x-axis, right? And now this equation here is the new one. Y equals the negative of that whole thing. So negative x squared plus 2x plus 3. And the reason why you have a negative is because you'd have a negative in front because you have a reflection in the x-axis. And remember, reflection in the x-axis is a negative in front of your brackets. So if you had a reflection in the x-axis, you'd have to have a negative applied to the whole thing. Changes the whole equation. All right, now we can do our pieces. Y equals, and I always work from left to right, x squared minus 2x minus 3 if x is less than negative 1, because that's the point they share. Then between negative 1 and 3, I follow the new equation. Negative x squared plus 2x plus 3 if negative 1 is less than x is less than 3. And these ones I put the equal to's on. So you can either put the equals on the middle ones or the equals on the two outside ones, but I always like putting it on the middle. You can't put it on all of them. And then x squared minus 2x minus 3 comes back, because that's this arm, if x is greater than 3. That's all piecewise functions are. A lot of people try doing it without finding the x-intercepts or graphing it. It's just not going to happen. It's a lot easier if you can let yourself see what it is. Okay? The last thing we did with absolutes was we did solving absolutes. And because every negative and positive case becomes positive because it's the distance from 0, when you solve the absolutes, you get two cases. On the test, I can't tell you how many of you always give me one case. A positive and a negative. You always get two cases, always, always, always. So let's do the basic one first. Solve absolute value of x minus 3 equals 7. Absolute value of x minus 3 equals 7. So remember with radicals, we always had to check our answers. We went over that yesterday. With radicals, you always have to check your answers, because just because you get an answer doesn't mean it actually works in the check. Same thing with absolutes. You'll get your two cases, but you always have to check them, because just because you get two answers doesn't mean they actually work. Remember, you can also check these with your calculator too, y1, y2, and find out where they can intersect. Remember? So we're going to do it algebraically, and then we'll check it graphically after. So, and we'll check it by algebra too. Case 1. You drop the absolutes and put a plus sign in front. Case 2. You drop the absolutes and put a minus sign in front. Okay? The reason why we do that is the absolute values cover all the positives and negatives, so we have to do 2 cases. So now we just solve them. We get x minus 3 equals 7 because a positive in front isn't going to change anything. Move our 3 over, and we get x equals 10. Then we distribute a negative in. Negative x plus 3 equals 7. Subtract the 3. Negative x equals 4. Divide by negative 1. X equals negative 4. Now, some people don't remember the 2 cases. I feel like it's a win if you remember those. But you can also get this wrong if it's a multiple choice and you don't check them. Because I'll have the multiple choice answer 10 and negative 4. I'll have the multiple choice answer just 10, and I'll have the multiple choice answer just negative 4, and usually no solution, because sometimes it doesn't cross at all, right? So you have to check them. When we check them, I always told you need to check them back into the typed equation, the one that I typed for you, right? The one that's on the test in the question. So we're going to put it back into here. Absolute value of 10 minus 3, absolute value equals 7. The absolute value of 7 equals 7. 7 equals 7. That is true, so this is true. Then you go absolute value of negative 4 minus 3 equals 7. Absolute value of negative 7 equals 7. 7 equals 7. That's true, and so is this. So actually our solution is both of them. Now, type this into your calculator in y1, y2. Then you do second, trace, 5, which is intersect, and then enter 3 times. Enter, enter, enter. And you'll get the x off of one of them. And you take that. You don't take the y's. You don't care what the y actual value is. And then you go to the other intersection and find it too. So try that with your calculator. Okay. Last example. I want you guys to try this one. Solve. Absolute value of 2x minus 5 equals another 2 terms, 5 minus 3x, a binomial. Try that one out. Okay. Case 1. Positive 2x minus 5 equals 5 minus 3x. Case 2. Negative 2x minus 5 equals 5 minus 3x. So 2x minus 5 equals 5 minus 3x. Add the 3x. Add the 5. So 5x equals 10. X equals 2. This you'll get negative 2x plus 5 equals 5 minus 3x. Add the 3x. Minus the 5. You get x equals 0. So you always have to check them back into the original equation. So check. Absolute value of 2 times 2 minus 5 absolute value equals 5 minus 3 times 2. Absolute value of 4 minus 5 equals 5 minus 6. Absolute value of negative 1 equals negative 1. Absolute value of negative 1 is 1. So if you forget to put the absolute value signs and you use it from this part, it'll be right every single time, which is not the case, right? You always have to check back into the typed equation, nothing that you have changed. So 1 doesn't equal -1, so x doesn't equal 2. Let me try 0. Check. Absolute value of 2 times 0 minus 5 equals 5 minus 3 times 0. Absolute value of -5 equals 5. 5 equals 5. So that's true. Okay? We're going to do one more that you can try. It's a quadratic, because remember, sometimes you're going to get an x squared, and if you get an x squared, you're going to actually get 2 answers for this one, 2 x's for this one, so you're going to be checking 4 x's. It's a big one when it's quadratic. So try this one. And then we're doing reciprocals. Solve absolute value of x minus 10 equals x squared minus 10x. Okay. Right? Okay. So case 1. Positive x minus 10 equals x squared minus 10x. Case 2. Negative x minus 10 equals x squared minus 10x. So it's going to be x minus 10 equals x squared minus 10x minus x plus 10. Why am I moving them all over here? Whenever you have an x squared, you have to move everything to one side, set it equal to 0. X squared minus 11x plus 10. What multiplies to give you 10 and adds to give you -11? X minus 10, x minus 1. So x equals 10 and x equals 1. That's a 10. Remember to check them. Then negative x plus 10 equals x squared minus 10x. Add x minus 10. 0 equals x squared minus 9x minus 10. So 0 equals, multiplies to give you -10 and adds to give you -9. X minus 10, x plus 1. So x equals 10 and -1. And then we have to check them. What was the original equation? Absolute value of 10 minus 10 equals 10 squared minus 10 times 10. 0 equal, absolute value of 0 equals 100 minus 100. 0 equals 0. So 10 is good. That's x equals 10. X equals 1. Absolute value of 1 minus 10 equals 1 squared minus 10 times 1. Absolute value of -9 equals 1 minus 10. 9 equals -10. Is that true? No, so that's not true. So that's not true. So if I asked you for the extraneous roots, you'd tell me this one, right? Extraneous means doesn't work, but you could find it. And that's a way that I can ask you to solve this without you having your calculator. So if I asked for extraneous root, you couldn't put this into your calculator and just do y1, y2, because you'd never know which ones don't work because it doesn't show up on the calculator. 10 we've already checked. Now we're going to check -1. Absolute value of -1 minus 10 equals -1 squared minus 10 times -1. Absolute value of -11 equals 1 plus 10. 11 equals 11. So that one's good too. So our answers are x equals 10 and -1. Okay? Then we did reciprocals. So if I gave you f of x equals x plus 3, and I asked you for y equals 1 over f of x. Or I ask you for the reciprocal. The reciprocal is just 1 over the function itself. So either one of those works. So y would equal 1 over x plus 3, right? Now remember, your horizontal asymptote is y equals 0. Always for you guys, which is nice. The vertical asymptote is what your x can't be, because it's the line where the x doesn't exist. So where doesn't x exist on here? -3. So my vertical asymptote is going to be at x equals -3. So if I go to sketch this graph, at x equals -3, I'm going to have myself a vertical asymptote. And at y equals 0, on the x-axis, I'm going to have a horizontal asymptote. Because that's how you can draw the graph. Now, the great thing about this is I can ask you for the domain and the range. The domain is just everything but what x can't be. So it's going to be x such that x can't equal -3 xer. Because every other x value exists. The range is y such that y can't equal 0 yer. Now if we want to sketch this graph, we have to draw the original. So I'm going to draw the original in green. The original is x plus 3. So at 3, and then I'm going to go up 1, right 1. Up 1, right 1. Up 1, right 1. Up 1, right 1. Down 1, left 1. Down 1, left 1. Down 1, left 1. Down 1, left 1. Wow, it's not very straight, but pretend it is. So that's the x plus 3 graph. This is the original graph. Guys, why is there an asymptote running through the x-intercept of the original graph? Because you're always going to take every point off the original. You're going to keep the x value, and you do 1 over every y, right? 1 over every y. What's the y of an x-intercept? What's 1 over 0? Undefined. 1 over 0 is going to error in the calculator. And that's why you get a dashed line added on the reciprocal graph, because what you're doing is 1 over 0, and it's undefined. So it's undefined at that x value. So for everywhere along that x value, you're going to have a dashed line, because there's no x value that exists there, because it would be 1 over y. So 1 over 0. Now, remember the invariant points always happen at y equals 1 and y equals -1. The invariant points for reciprocal graphs happen at y equals 1 and -1. Why is that? Because when you do 1 divided by 1, what do you get? 1, so it stays the same. When you do 1 divided by -1, what do you get? -1, so it stays the same. What if your original y was 2 and you did 1 divided by 2? That's a half. Are those the same? No. Invariant points means they don't change. So the only points that are going to stay the same are the ones where y equals 1. So I go to wherever the heck y equals 1, and I replot those points because they're staying. Then every other point I have, I drop below 1 and redraw it. So this one's at -2. 1 divided by -2 is a half, -1/2. So I'm going to redraw it here. I'm going to go to this one. This one's at 2. 1 divided by 2 is a half. So I'm going to stay on the same x, but I'm going to draw it at a half now. This is at 3. 1 divided by 3 is a third. So it's even a little lower. A quarter. And then like this. So what's happening is, remember, it's running along your asymptotes. So it's going to go like this. Run down. I'll go like this. Yeah. So what you could do, if I asked you for what the invariant points are, remember you have to do that. If I have asked you what the invariant points are, you actually have to put them back into the original and solve. So if I ask you for invariant points, you're going to go x equals what when y equals 1 for your one invariant point, and x equals what when y equals -1 for your other invariant point. And you plug it back into your original equation, because if it's an invariant point, it doesn't change. The original equation is y equals x plus 3. So y is 1. 1 equals x plus 3. Subtract 3. X equals -2. So your one invariant point is at -2 and 1. Then this one, you're going to go y equals x plus 3. But instead of putting in a positive 1, you're going to put in a -1. -1 equals x plus 3. Subtract 3. X equals -4. So you're at -4 and -1 is your other invariant point, which we could see off the graph. It's basically reciprocals. Okay, then we did systems of equations, and then we did inequalities. So we just have the 2 lessons left. Well, yeah, kind of. The 2 units left. So that's when you could have a linear with a linear or a linear with a quadratic, and you have to find out where they intersect. So when you have 2 systems of equations, you're finding the intersection points, or point. Or there may be none. If it's like a quadratic and a quadratic, right, you wouldn't have it cross at all. You guys did linear in grade 10. You don't do linear this year. You do either linear quadratic or quadratic quadratic. So let's try this one. Solve. 4x minus y plus 3 equals 0. 2x squared minus 8x minus y plus 3 equals 0. Oh my gosh. All right. If it's not a written response, which it probably will be, or it'll be in a numeric or a written, it usually, because it's a unit, right? There's a whole unit on just this. So it's probably gonna appear somewhere. Well, the whole unit is, there's the 2 lessons. There's either where you can do it graphically, solving graphically, or solving algebraically. Yeah, it was only a 2 lesson unit. It's very short. So remember, we put the 2 units together because they are so short. So our first step, no matter whether you do it graphically or algebraically, remember, if I say algebraically on the test, you have to do it algebraically. If you just give me answers, I'm going to be like, yeah, no, you didn't. You'd be like, I did it in my head. No, you didn't. Yeah, exactly. So, yeah. So either graphically or algebraically follows the same first step. What did we get them into? Y equals. So I'm going to move the y over. 4x plus 3 equals y. And then that one I'm going to go 2x squared minus 8x plus 3 equals y. You have to find that out with your calculator. So everyone, punch this into your y1, punch this into your y2. Punch into your y1 and punch into your... So remember on your calculator, when it's anything e to the negative anything, that means 0, right? So if it's like 2.3777, e to the negative 10, that's just 0.9 zeros, 2. We can round that to 0, right? So always look for that e to the negative something. That's just 0. Please don't write 2.2 or something like that. That's not what the answer is. Okay, so when you do these, you get 0 and 3. What did I say the other one was? Negative. Is it really 0 and 3 though? Yeah? And then I did not write the question down the same as textbook. So what's the other one? 6 and 27. Okay, now let's do it algebraically. And if you're like, I'm just going to do it graphically no matter what, if it's a written response, that's like 2 or 3 marks on your diploma or final. I'm so used to saying diploma. You're going to be sad, crying, upset. Or you're going to be trying to cheat me out and show me how you did it, pretending to do it algebraically and give me a graphical answer at the end, which is not going to happen. Okay. So what do? We get it into our y equals first, which we did already. Then we can set them equal to each other. Because remember, y equals y. So then this must equal this. So 4x plus 3 equals 2x squared minus 8x plus 3. Then what do we do whenever we have a squared? Move everything to one side. Yeah, y equals y. This equals y, that equals y, so I can set them equal to each other. So move them over, minus 4x, minus 3, 0 equals 2x squared minus 12x. So this one, you could put in the quadratic formula if you wanted to. You'd just make c be 0, okay, if you actually did put this one in. Or you can say, hey, I can take a 2x out. It's just a GCF. Take out a 2x and you're left with x minus 6. So x equals 0 is my one answer because of this one. And x equals 6 is my other answer. And then everyone stops and says, hey, I'm done. And I say, solve two systems means find the points of intersection. Point means x and y. Everyone forgets to find the y's. Now you can either plug it back into this one or this one to get the y. Because if you go 2x equals 0, divide by 2. So you can plug it back into the top equation or the bottom equation. I would plug it into the linear one if I have a choice. If it's quadratic, you don't. But if it's linear and quadratic, I always plug it into the linear one just because it's less steps. But you could plug it into the quadratic. So y equals 4x plus 3. So y equals 4 times 0 plus 3. So y equals 3. So my one point is at 0 and 3. Then I'm going to have y equals 4 times 6 plus 3. Y equals 24 plus 3. Y equals 27. And honestly, some people are bad at changing the windows on calculators, and algebraically is even better because you don't have a window to deal with. Now I'm making you do a quadratic, and then we'll do inequalities. And remember, there's word problems in these two that you'd have to do. What happens when it's the end of the year? Okay. Solve 2x squared plus 16x plus y equals negative 26. And x squared plus 8x minus y equals negative 19. Or factor if you can. Sometimes you can. Sometimes you have to quadratic formula. So you're going to do it algebraically and graphically, and go. Yeah. Okay, first step is getting to y equals. So I'm going to move these over there. 2x squared plus 16x plus y. Subtract 2x squared, subtract 16x. Because I want a positive y. So y equals negative 2x squared minus 16x minus 26. Then I'm going to do the other one. X squared plus 8x minus y equals negative 19. I'm going to move the y and the 19 because I want a positive y. So I'm going to get y equals x squared plus 8x plus 19. Now I have them in y equals, so I can set them equal to each other. So, negative 2x squared minus 16x minus 26, because y equals y, right? Equals x squared plus 8x plus 19. I personally myself like dealing with x squareds as positives first. So I'm going to move this to this side. It's easier to factor with a positive than it is with a negative. So you get 0 equals 3x squared plus 24x plus 45. Then we ask ourselves, can we take a 3 out of all of them? Because if we can, then we could do product sum instead of decomp. Can you take a 3 out of 24? Can you take a 3 out of 45? Yes. You need JO here to answer your questions. It works. Okay. So x squared plus 8x plus 15. Does this 3 affect my x's? No. Because it's just coefficient out front. And we say what times what equals 15? What plus what equals 8? What do we get, Cole? Cole? Mm-hmm. And then we can go right to brackets. X equals negative 3, x equals negative 5. And then what do we have to do? Find the y. Either of these stuck. Lack of better words, I'm going to use this one. Because I don't want a negative x squared. So y equals negative 3 squared plus 8 times negative 3 plus 19. Y equals 9 minus 24 plus 19. Y equals 28 minus 24. Y equals 4. So negative 3 and 4. Remember to find your y's. You guys always forget. And then we do the other one. Y equals negative 5 squared plus 8 times negative 5 plus 19. 25 plus 40 plus 19. Oh my goodness. Minus 40. That's better. So 25 plus 19 is 34. Minus 40 is negative what? Starts with an S, rhymes with tricks. It's a, come on, Jade. Rhymes with tricks, starts with an S. Rhymes with X, starts with an S. Thank you. Okay, check it on your calculator. This is 4. It would have been better as a 6 because it made it rhyme, but it doesn't work out that way. Negative 40, positive 36, 4. Negative 4. Negative 4. I'm jumping out a window. This is some bad math. I'm jumping out a window. No, that's not quadratic formula. That's just pure English, like math.
I think we can quadratic formula. We can't add or subtract. It's a joke.
Oh, and then we can't add or subtract at the end. Yeah. And it's not we. It's just me. And then I confuse Jade because it rhymes with 6, and it's not even a 6. All right, so the only catch on linear for the most part, and on quadratic as well, is if you divide by a negative, what happens to the inequality sign? So you get negative y is less than or equal to negative 2x plus 10. And for ease of being able to do this properly, I would always leave the y on the left. I know some people want to make the y on the right and make it better, but people find reading the inequality signs hard if they're reading from the left. So always just leave your y on the left-hand side, and then you aren't reading towards the left. Like people reading from the left, from the right to the left, find it way harder. So always just leave your y on the left is my point. Because what some people do is they'll take this y and they'll move it over here so that's a positive, and then they don't have to divide, right? And then you're reading y is greater than or equal to, but people don't read well from the left. No. If you can read from the y towards the inequality sign, people are just really good at going, oh, if it's like this way, then it's less than. If it's this way, it's greater. However, if you have the y on that side, that rule doesn't work. Yes. Yes. I always just, for ease of people not reading it backwards, I always just leave the y on the left. Either way, it's still greater than. It's just that if people have it like this instead, some people will still think it's less than because they read that as a less than. But it's not less than. You're reading from the y. So this is actually y is greater than or equal to that. So I find people find it just easier if they leave the y on the left than trying to read this way. Okay? So then we draw the graph. What do we have to remember? Dotted or solid? Dotted or solid? Always, when it's a quadratic or a linear inequality. Is our line going to be dotted or solid? Because it's, okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 is my y-intercept. Up to right 1. Up to right 1. Up to right 1. This is a really accurate graph. No. This hurts. Yeah, it's really good. Okay, now how do we decide where to shade? Test point. And I always use test points off the x-axis. And if the line doesn't go through 0, 0, I always use 0, 0. So I'm going to try it out. 0 is greater than or equal to 2 times 0 minus 10. 0 is greater than or equal to negative 10. Is 0 greater than or equal to negative 10? Yes, if you have $0, is that more than if you have no dollars, like negative $10? Yes. No. Yes. Okay. So is that true? Yes. Then that means the test point is in the solution. So that means I shade where it is. So if it's true, the test point is in the solution. So now what would work on this? Any answer that's in here and any line that's on any point that's on that line would be in the solution. Okay? Now, closed dot. Because it's equal to that. Because you don't want an open dot would mean that it's open. There's nothing there. So open means not equal to. Yes.
Oh, okay, never mind.
Speak, Jade. I'm waiting you out. Can you not go now? Quadratic inequality. Then you're done. You still have to do work. No, quadratic inequality gives you a number line in a state or a region, and you guys stink at that, so we're going to go over it. I don't remember. So negative x squared, solve. Solve means give me a solution. X squared plus x plus 12 is less than 0. So when we factor this, you guys, you have to do decomp because there's a negative 1 in front, and everyone still does product sum because they think so, but you don't. So what times what equals negative 12? What plus what equals 1? Positive 4, negative 3. And you have to do decomp because it's a negative 1 in front. Negative 1x squared plus 4x minus 3x plus 12 is less than 0. Just decomp, guys. Just decomp.
deviate on the thumb.
Because you just thought that was an absolute sign. So you just write it down. Like it, be it, you are it. Okay, take a negative 1 x out and you're left with x minus 4. Take out a negative 3 and you're left with x minus 4 is less than 0. Negative x minus 3. X minus 4 is less than 0. So negative x minus 3 equals 0. Negative x equals 3. X equals negative 3. X equals 4. So those are my x-intercepts. So I go. Now. Just plotting x-intercepts, guys. If you weren't on your phone, you wouldn't have a problem. It was bright.
Because I just looked at it. I thought Jody had
Hence on your fin.
I said, no, Mom.
I'm math.
Busy studying for math.
I'm mathing right now. I'm mathing right now. I'm not dorying. I'm mathing. Okay. Put this into your calculator, you guys, and you need to find the maximum so we can actually sketch it. Negative x squared plus x plus 12. Sounds like me doing that math answer. Like, where'd you go? But if you want to like go to like a movie and you know like 2 of you are going or something, the Costco one's really the way to go. The Costco has like. That's true. I also, Okotoks, I know it's not like the highest of, but it's way cheaper.
You can literally take $20
If you have $20, you can get 2 bottles of what? Mountain Dew Voltage. Not just Mountain Dew, a large popcorn at Okotoks Theater and the ticket. This commercial is brought to you by Cole Haberlack. So if you are feeling the need to go see Dory when it comes out, Cole Haberlack has promoted the Okotoks Theater. Do you realize I'm sending a commercial right now for anyone who's going to watch this? I just commercialed it by Cole Haberlack for the Okotoks movie theaters. I know. I'm choosing to do this. For the fact that they just had to deal with me like mutilating the last adding. Now they get this. Okay. So this is at 0.5, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 0.25. 0.5 and 12.25. Right here. Bam. Shabammy bam. Is the vertex. And then we're going to. Yep. It is. And then this is a dashy dashed line. Because. You know what? That's because you were talking about your Mountain Dew Voltage popcorn ordeal. And a large popcorn. Oh, butter's 25 cents? If you 25 cents and ridiculous in the same sentence? Do you know how much everything else costs? Thank you. But just wait. We can be done. Okay, we do a test point. 0, 0. Let's test it. Negative 0 squared plus 0 plus 12 is less than 0. Is 12 less than 0? Shh. Is 12 less than 0? No. So we shade out here, which means we shade on here. There's our number line. So our number line is open dot, negative 3. Open dot, 4. Yeah, or you're wrong. And I'm proctoring it tomorrow, so if I don't hear the zhuzh, I'm not going to. Yes, it's tomorrow. That's why you can't go to Dory. Come on. So you're going to have x is less than -3 or x is greater than 4. If it is the arms, you cannot write them together as one. You can do that, but you will be wrong. People are like, yeah, I still read it together. I'm like, I know that, but that's still wrong. So don't do it.